Welcome back. In this video, we are going to take a look at multiplying and dividing rational expressions, or multiplying and dividing fractions. And multiplying fractions is quite a bit easier than adding and subtracting them because we don't need a common denominator when multiplying fractions. Remember, we just multiply numerator times numerator and denominator times denominator. But since we're working with rational expressions and we've got polynomials, we're going to have a little bit more complicated type fractions. You'll have to do some factoring, and of course remember, we only cancel factors and not terms. So from our simplifying rational expressions, we remember that if we have factors and fractions, if we have a times c over b times c, that is equal to a over b, because c over c cancels. Anything divided by itself is 1. So this is really a over b times 1. So it simplifies to 1. We usually use the fact that they cancel, but it simplifies to 1. And of course, that's our fundamental property. Well, multiplying rational expressions is going to be a process very similar to what we have done before. Okay? We will want to factor both the numerator and the denominator. We want to factor first. We do not cancel first, we factor first. And in doing so, we follow the rules for factoring. We first look for the greatest common factor. Then we look for our patterns, differences of two squares, perfect square trinomials, sum and differences of cubes, those kinds of things. Then we might look for an ordinary pair of binomial factors, just plain old factoring, especially if a is equal to 1. If a is not equal to 1, well, then we might factor by grouping, or we would do that guess and check method. And of course, when you think you're done factoring, look again. Look for the GCF, look for a difference of two squares. Those are the things that come up every once in a while. And then finally, simplify. Apply the fundamental property, cancel common factors. Okay, be careful to cancel factors and not terms, and we will be cross-canceling here, and that is okay to do. And then you will leave your final answer, both numerator and denominator, in factored form, so we will not re-multiply back at the end. Dividing rational expressions. The process is very similar to multiplication, but in dividing, we will multiply by the reciprocal of the factor to the right of the division symbol. So take the factor to the right of the division symbol, flip that, and multiply. Thus, we are going to multiply by the reciprocal. That's our definition of division. And then we'll follow the process that we stated above. So here are some samples. Complete the operation indicated. So let's begin over here. Negative 5x cubed over 3y cubed times 2y squared over 15x. The temptation here is to multiply negative 5 times 2 and make that negative 10, and 3 times 15 and make that 45. But you're better off working with smaller numbers rather than larger numbers. So let's go ahead and simplify. 5 over 15 is 1 over 3. We still have our negative sign. And x cubed over x, well, that will simplify to x squared. And then we have y squared over y cubed, so both factors of y will cancel, and leaving with one factor of y. So it looks like my leftovers is negative 2x squared all over 3 times 3 is 9 y. And that, I'll take a look again. My constants are simplified, my coefficients are reduced. X squared over y, there's nothing to simplify there. So I have completed the operation. I've multiplied those two fractions and got my final answer. Now we have a couple polynomial rational expressions that we are multiplying here. I've got the polynomial x squared plus 2x over x squared minus 4 times x squared minus 4x plus 4 all over x squared minus x. So we go back to our suggestions. We want to factor first. So out of the numerator on the left, I'm going to factor out an x, and I'm left with x plus 2. Remember, we always want to factor first. The denominator has a difference of 2 squares, which I can factor to x plus 2 times x minus 2. That'd be a 2. Times my numerator here in x squared minus 4x plus 4 is a perfect square trinomial. That's 2 times a times b, so times x minus 2 quantity squared. I have 2 factors of x minus 2. And in the denominator, I'll factor out an x, and I get x times x minus 1. So now I can go ahead and I can begin simplifying. I'll apply the fundamental property. X squared over x squared is 1. So those simplify to 1. And I have a factor of x minus 2, which can simplify with one of these factors of x minus 2 in the numerator. And x over x will simplify. So it looks like my numerator, I have x minus 2 all over x minus 1. You don't necessarily need the parentheses here. I can get rid of those now. And of course, be careful. We don't cancel x over x. This answer is not positive 2. These x's are terms and not factors because they're being added and subtracted. So that is our final answer. Our next sample problems are a couple of division problems. 7x squared y over 3xy squared divided by 21x squared y squared over 14xy. So I'm going to rewrite my problem. 7x squared y all over 3xy squared times, and multiply by the reciprocal. So I flip my fraction and multiply. And now I can do some simplifying. It looks like 14 and 21. That has a common factor of 7. So that simplifies to 2 and 3. I can cancel, looks like I can cross cancel x squared and x squared. I can cross cancel x and x. And I have, looks like my denominator, I have 4 factors of y. I have 2 factors of y in the numerator. So I will cancel those 2 factors of y with this y squared. Let's see what we got here. It looks like we have 7 times 2. So we have 14 all over 3 times 3 y squared all over 9y squared. Let's take a look. Am I done? Have I completed all the simplifying? I don't have any common factors in 14 and 9. It looks like I am all set. There's my final answer, 14 over 9y squared. In our next sample problem, 3 minus x. I'd like that a lot more if it was x minus 3. Looks like we're going to do some big time factoring here. We're dividing, so I'm going to multiply by the reciprocal. So I'm going to factor negative 1 out of the numerator on the left. So I have the opposite of x minus 3. And I'll factor the denominator. Factors of 5 that add up to 6. So x plus 5 times x plus 1. And I'm going to flip and factor at the same time here to save myself a little space. So my denominator factored in my numerator becomes 2 times x plus 5. And my numerator factors into x minus 4 times x minus 3. So now I've factored everything, I've flipped my fraction, I've taken my reciprocal, and now I can go ahead and start applying the fundamental property, cancel the x plus 5s, the x minus 3s will cancel. I have the opposite of 2 in my numerator, and my denominator has x plus 1 times x minus 4. Doesn't look like we can cancel anything else, so there's our final answer. And you might see this written as the opposite of 2 all over x plus 1 times x minus 4. Either of those is correct. Another division problem. We have 10x plus 4 divided by. So again, I'm going to factor. Looks like I can factor 2 out of the numerator. So I have 2 times 5x plus 2. I have a difference of 2 squares in my denominator. X plus 2 times x minus 2 times x plus 2. My denominator here becomes my numerator. And I can factor out an x squared. And I am left with 5x plus 2. And I can go ahead and apply the fundamental property. The 5x plus 2 simplify. The x plus 2 simplify. And I have 2 all over x squared times x minus 2. And there is your lesson on multiplying and dividing rational expressions, and we'll see you in class.